Today I will be sharing with you my experience on the topic Toposequential Landuse System for Resource Conservation and Economic Upliftment in Shiwaliks. Toposequential Landuse System means land use system which is applicable for the slopy lands. So in India, out of 328 million hectare geographical area, 93 million hectare or about 28% area is mountainous and majority of it is in Himalayas. Shiwalik Himalayas, which are outer Himalayas, they are spread in an area of 3.33 million hectare area covering Jammu, Himachal Pradesh, Uttarakhand, Punjab and Haryana. This Shiwalik Himalayas comprise of two parts, Shiwalik Hills and Piedmont Plains. The soil profile of this region is shown in the photograph, and the area being rain-fed has gravelly kind of soils, and in addition to that, slopy area makes canal irrigation not feasible for this region. The groundwater table is also very deep, and hence the problem of crop failure generally occurs. These slopy lands, when they are not covered with any crops or cultivation is not there, these lands gets infested with lantana camara, which is an obnoxious shrub, and thus it converts a good fertile land into a degraded land. The need is to utilize these sloping lands to some purpose. So to utilize these sloping lands, we had three interventions. One was Toposequential Landuse System model with water harvesting, because of lack of sufficient moisture, the crops generally fail. Second is Toposequential Landuse System model with in situ moisture conservation practices and traditional practice for managing the sloping land, that is control, which is being followed by the farmer. So we took a 3 hectare land and divided it into 3 parts, 1 hectare each. This is the contour survey of the land, so that we can find it out which is the best suitable place for harvesting water. So TLS1 is Toposequential Landuse System 1, where water harvesting is one of the component. TLS2 means where Toposequential Landuse System, where in situ moisture conservation practices was followed, and 3.1 control is the farmer practice, which is before. So in plain area cultivation is done, and in sloping area it is left for natural regeneration to come. So this 3 hectare land was planned to be converted in this way. TLS1 on upper part, upper 1/3 part, permanent tree cover with grass, middle 1/3 part converted into terrace and agriculture crops are grown, and the lower 1/3 part was devoted for pure agriculture along with water harvesting. In similar way, TLS2, except for water harvesting component, all 3 components were kept as that for TLS1. The farmer practices was followed like in plain area agriculture was done, and in slopy lands no cultivation was done, only natural regeneration was allowed, both for tree as well as grasses. In all 3 land use system, gauging stations were installed to measure runoff and soil loss, which are originating from this 1 hectare land use system each. This was the schematic view of the model which we intended to develop. Upper 1/3 silvipasture or horti silvipasture system, middle one hedgerow intercropping, and the lowest 1/3 portion converted into agriculture crops with aqua forestry. So this is the Google Earth imagery which we captured and here Silvi hortipasture, hedgerow intercropping and pond location have been shown. So on the upper 1/3 portion of both the treatments, trees were grown, fodder trees, timber trees, Emilia azadire and Imblica officinalis amla were planted. So since the area has very less irrigation facilities in initial years, so water conservation practice was followed, trench cum pit method. Then the terraces were prepared in the middle 1/3 portion. However, you can see within one rainy season there was so much of soil erosion. The terrace risers were damaged, and these are the site for soil erosion. So to check further soil erosion, Lucina leucocephala trees were planted on the shoulder bunds, and these were planted at a distance of 1 meter and kept as a hedgerow. Then on these terrace risers, guava was also planted, one after every 5-meter interval. This is the condition of the terraces which were prepared. Gravel was 25 to 30%, and it is generally the case of Shiwaliks quinoa. Crops like maize, taramira, mustard, these were grown on these terraces. Water scarcity was there. There's one water harvesting pond was dug at the bottom of TLS1. So this the capacity of the pond was 0.12 hectare meter. However, because of the gravel percent, high seepage was there. To check seepage, lining was done with the pond was lined with LDP sheet, and it was this LDP sheet is not UV stabilized. Therefore, to protect this sheet, a cover of cement to soil ratio of 1:6 was done. So this cement soil cover will also protect the LDP sheet from mechanical puncture as well as from the sunlight whenever water recedes in the pond. So as a result of this treatment, there was a reduction in the seepage, and hence water was stored in the pond. This pond was later on used for fish cultivation. So in general, on the upper part, 1/3 part of LS1 and 2, Silvi hortipasture system was developed. In middle 1/3, hedgerow intercropping was developed. Lucina leucocephala was pruned or hedged back twice or thrice in a year, so that it is not allowed to go beyond 1 meter, because it will be posing, otherwise it will be posing shade to the agriculture crops grown on the terrace. So after every 5 meter, a guava plant was also planted. So this is the guava plant which is here in the middle photograph of the hedgerow intercrop. And in the lower portion, pure agriculture was done. This water which got accumulated in the pond was circulated or recycled to the agriculture crops during winter season. There can be siltation of this pond, and its capacity will be reduced in future. So to avoid such kind of siltation, a silt trap was also created of 1 by 1 meter by 1 meter, and all the water which is to be stored in the pond was passed through this silt trap. Thus, whatsoever silt was there, it got deposited in the silt trap. After the rainy season was over, this silt was flowed back to the agriculture field. Thus, the fertile soil remains in the field and the pond is not silted. So, resource conservation capability of toposequential land use system. So runoff and soil loss measurement was done, as I told that a gauging station was installed. So the toposequential land use system or SALT 1 and farmer practices was compared, and it was found that the runoff in both the cases increased, but the runoff in farmer practices was higher. The soil loss which was measured in tons per hectare per year in Toposequential Land Use System 1. Initially, the soil loss was 1.03 tons per hectare per year. However, in final year, that is after 5 years of establishment, it got reduced to 0.12 hectares. That means almost negligible. This shows that resource conservation capability of the system as the vegetation part, that is trees and grasses, increased, the soil loss decreased. Whereas in case of farmer practice, the soil loss kept on increasing, and thus resource loss is there. You can see in runoff, in SALT 1, it had increased. However, when vegetation is grown, the runoff should have decreased. However, it had increased because our objective was that we want water in the pond. So what we did is, during rainy season, the water was channelized into the pond. So when we channelize the water into the pond, the runoff increases. But since it was channelized in a proper way, thus the runoff with the runoff soil loss was less. Thus the soil loss decreased. Now, in Shiwalik Himalayas, we have a particular typical rainfall trend. In January, February, March, April, May, and June, the rainfall is less, evapotranspiration is more. However, in July, August, and September, the rainfall is more and evapotranspiration is less. So, the strategy should be, because this is a water deficient area, the strategy should be harvest when it is more and utilize when it is scanty. So through pond this can be achieved when during July, August, September, the water which otherwise goes waste is harvested and can be utilized in the rainfall deficit season, shown in dotted line. So however, I told you that seepage is very high. This seepage is shown in this graph. There is a steep slope in the graph that shows that water recedes very quickly. So after lining, this slope was reduced, and now seepage has reduced. So whatsoever decline is there, it is because of evaporation. The cost of construction of the farm pond. The size of the farm pond which was created was 20 meter by 25 meter into 2.75 meter was the depth. And the cost of LDP, laying of the polythene, cost of the bricks for laying on the LDP sheet, and filling the block of soil and cement mixture. So in all, the total cost was 2,22,000 rupees, and the water harvested is about 1,200 cubic meters. So the cost per cubic meter of water stored is 185. So what the system is producing? The system is able to provide fresh weight and in terms of grass and fodder and fuel wood. So both in Rabi as well as in Kharif. Economics of Toposequential Land Use System model. on actual area basis, this has been converted because the area taken was 1 hectare each. So the benefit cost ratio of toposequential land use system where water harvesting was there was 1.41, and without water it was 1.16. In farmer practice it is negative because of crop failure. The net present value at 8% discount factor for the land use system where water harvesting was one of the component is 1,92,000. However, where without water harvesting it has reduced to 45,000 rupees. So there is a huge difference in system NPV when water harvesting is done and when water harvesting is not done. The payback period, in payback period, if we take only initial investment, then the payback period is 5.7 years, and when it is taken up to 10 years, because media rotation age is 10 years, then its payback period is 7.2 years. However, in this case, without water harvesting, the initial investment can be recovered in lesser time period than TSL1, because in TSL1 the investment cost was more because of construction of the farm pond. But however, as the time increases, so the payback period of the system without water harvesting is more, because by irrigating the crops through water harvested, the production will be more and hence economics will be much better. Now, if we take only the payback period of cost of construction of the pond only, and one crop, that is wheat, is taken. So this is an example. If wheat is irrigated, 5 centimeter irrigation is given. No irrigation, then wheat yield in this area would be 9.5 quintal per hectare. With one irrigation, it increases tremendously to 20.72 quintal per hectare, and with two irrigation, still more production can be achieved, 36.97 quintal per hectare. Taking into account 30% dead storage of the water in the pond, area which can be irrigated with the harvested water, that is about 1200 cubic meter. One irrigation, if we give one irrigation, only 1.8 hectare area can be irrigated, and if we give two irrigation, 2.9 hectare area can be irrigated with the stored water. So total grain yield by irrigating this area, 1.8 hectare area, with one irrigation will be 37.3 quintal per hectare, for two irrigation 33.3 quintal per hectare. The gross return from production is 52,000 rupees for one irrigation, and for two irrigation 46,000. The cost incurred in construction of the pond, previously was estimate was given, so it is 2.2 lakh 22,000. Thus, the payback period, if for the pond, is 4.25 year if one irrigation is given to the wheat crop, and two irrigation is 4.76 year if two irrigation is. So this has been calculated on the basis of the MSP of the wheat, rupees 1,400 per quintal. So taking the gist of the output from the system. So this toposequential land use system is capable of providing output in each quarter of the year. In January and March, we get amla and guava from the system, taramira or mustard during the winter season, and lucina hedgerow pruning. And after 10 years, melia can be harvested during the winter season, and a huge amount can be recovered. In second quarter, April to June, fodder maize can be planted, that is in the month of May and June. Short duration fodder maize can be planted. And the fodder Leucaena hedgerow pruning can be harvested again from the system. In third quarter, July, September, fruits guava, the second crop of the guava. One crop is in winter, another crop is in rainy season. So guava, Leucaena hedgerow pruning, and the harvested rainwater also. In October, December, crops like til, kulthi, etc. will be harvested. Maize, if it is planted in July or September quarter, so maize can be harvested in October, December. And the fish. This fish component is important because the pond will be filled in the month of July after 1 or 2 or 3 showers, and this water will not be utilized for any purposes up till winter, because rainy season is there. So up till winter, this water will not be utilized. So up till then, this water can be used for rearing of the fishes. So if in July we stock the water with the fingerlings, fish fingerlings, and if we provide them with fish feed and with some exercise, so the 1 gram or 2 gram fish will be now in December will be equal to about half a kg or so, and that can be harvested because that the stored water is now being utilized for irrigating, pre-sowing irrigation for the winter crop, that is wheat or whatever crop is to be planted. So that way a farmer will be able to get some kind of income from each quarter of the year. Thus, with this land use system, the sloping land which was otherwise infested with lantana camara and was not providing any income, so that can be transformed into this beautiful pictorial thing where fodder, fuel, timber, fish, and 2 crops and fruits can be harvested. That is around 5 or 6 components can be obtained from the same land use system. So for further inquiry, you can contact the director or head of the Indian Institute of Soil and Water Conservation Research Center, Chandigarh. Thank you very much.